Hello, my name is Sheetal, and today I'll be presenting the work I did for my ECE 570 project, which was to re-implement VQ-VAE-2 from scratch. VQ-VAE, or Vector Quantized Variational Autoencoders, is a technique that's used to achieve high-quality image reconstruction. For my project, I attempted to implement this structure for the CFAR10 dataset, and my main goal was to achieve similar reconstruction quality to the baseline. The idea of image reconstruction comes from the overarching task of generative AI. In order to generate high-quality images, efficient reconstruction becomes important. VQ-VAEs also serve as a better alternative to GANs to provide better diversity as well as fidelity in the generated images. The paper I selected proposes a two-stage solution. The first stage is to train a VQ-VAE model, and the second stage trains the prior from the VQ-VAE model on pixel CNN in order to generate new images. For my project, I focused on re-implementing the first stage, which was a novel concept introduced in the study. One important related work is the vanilla VQ-VAE that was introduced a couple of years before VQ-VAE-2. This model involves a very simple encoder, quantizer, decoder structure as shown in the image here. VQ-VAE-2 is essentially a hierarchical version of the vanilla VQ-VAE. Another interesting work is the image in painting task that involves filling in a missing or damaged region of an image. The study that I looked at uses VQ-VAE-2, but uses a different model to train the prior distribution. They achieved results that was even better than VQ-VAE-2. In order to implement VQ-VAE-2, I followed the diagram that was provided in the paper, shown here on the left. The input image is encoded by the bottom encoder, and that's fed to the top encoder. The output of the top encoder is quantized, decoded, and combined with the output of the bottom encoder. This combined tensor is quantized again before it is fed to the final decoder. The decoder uses the combined quantized tensors in order to reconstruct the images. The algorithm is provided here on the right, and this was used to implement the code. It's been adapted from the algorithm that was provided by the authors. As mentioned earlier, the dataset that was used to train the VQ-VAE model is the CFAR10 dataset. Evaluation was done qualitatively by visually comparing the image reconstructions with their original versions, and quantitative evaluation was done by training a simple image classification network to obtain classification accuracy scores, or CAS. We can see the loss for the three different models here. Vanilla VQ-VAE only deals with the mean squared error between the reconstructed and the original, whereas the VQ-VAE-2 has the additional embedded or latent loss. We can see that the losses for VQ-VAE-2 are noisy, but they do look similar for both the baseline and my implementation. Looking at the qualitative evaluation, on the left are the original images from the validation dataset. On the right is the reconstruction when using the vanilla VQ-VAE. We can see that the reconstructions are very blurry. However, when we use VQ-VAE-2, we achieve much better quality reconstructions, and to our eye, they look very similar to the original dataset. Additionally, the baseline and my implementation also look visually similar. The table here shows the values of the losses and CAS scores for each model. My implementation achieved significantly lower loss, most likely due to the specialized top versus bottom encoder-decoder structure that I implemented, which was different from the baseline. The CAS scores, as we see here, are similar for the baseline and my implementation. Since the goal of my project was to achieve results similar to the baseline, this was achieved as seen by the visual qualitative as well as the quantitative evaluation results. The key takeaways from this project is that the VQ-VAE model is a great solution for efficient image reconstruction, especially for highly compressed latent spaces. VQ-VAE-2 is a hierarchical version that produces even better quality images. While this is a good first step for image generation, the low CAS scores tell us that this type of compression needs further improvement in order to be used for image classification. Thank you.